Understand chemical equations. Chemical reactions. In chemical reactions, existing substances combine to form new substances. The substances that combine are reactants. The substances formed are products. Energy may be absorbed or released during a chemical reaction. New substances are produced during chemical reactions because the atoms making up the reactants bond in new ways. This change in the ways the atoms bond changes the chemical characteristics of the matter involved. Many substances react chemically with each other to form new substances. For example, many elements react to produce compounds. Many compounds react to produce other compounds. A chemical reaction can be represented in the following ways. Words: magnesium plus oxygen, rightward arrow, magnesium oxide. Symbols: 2 mg plus O, rightward arrow, 2 MgO2. Law of conservation of mass and balanced chemical equations. During a chemical reaction, the arrangement of atoms in the matter involved changes. However, the total number of each type of atom does not change. This scientific concept is the law of conservation of mass. A balanced chemical equation reflects the law of conservation of mass and provides accurate quantitative information about a chemical reaction. It tells not only the way that atoms are rearranged during the reaction but also the relative amounts of the substances that make up the reactants and products. An equation is balanced when the number of atoms of each type on one side equals the number of atoms of each type on the other side. The diagram identifies the parts of a balanced chemical equation. The equation represents the reaction of methane 4 and oxygen 2 to produce carbon dioxide 2 and water 2. Types of reactions. Different types of chemical reactions occur. In synthesis, 2 or more reactants combine to form a single product. The general form equation for this reaction type is A plus B, rightward arrow AB. In decomposition, a single reactant forms 2 or more products of rightward arrow A plus B. In single displacement, one element replaces another in a compound of plus C, rightward arrow AC plus B. In double displacement, two reactants form two new products of plus CD, rightward arrow AD plus CB. Limiting reactants. Depending on the amount of each reactant involved in a chemical reaction, a limiting reactant can exist. A limiting reactant limits the amount of product that can be formed because the reaction stops when all the limiting reactant is consumed. Consider the equation that represents the reaction of benzene 6,6 and oxygen 2 to produce carbon dioxide 2 and water 2. As with any reaction, the reaction represented by the equation can be limited, depending on the amounts of certain substances involved. Chemical reactions and conservation of mass. Chemical reactions occur when the particles that make up particular substances rearrange to form different substances. The substances involved initially are reactants. The new substances formed are products. Matter cannot be created or destroyed when a chemical reaction occurs. This concept is known as the law of conservation of mass. Because of conservation of mass, a chemical equation must be balanced. That is, it must have equal amounts of each type of atom on both sides of its directional arrow. For example, the chemical equation below represents the reaction that produces water, 2. The equation is balanced because the number of hydrogen atoms on one side equals the number of hydrogen atoms on the other side, and the number of oxygen atoms on one side equals the number of oxygen atoms on the other side. Types of chemical reactions. Various events can take place during chemical reactions. For example, in the chemical reaction that produces water, two substances combine to form one different substance. Chemical reactions can be classified by type, depending on what happens when they occur. In a synthesis reaction A plus B, rightward arrow AB, two or more reactants combine to form a single product. In a decomposition reaction of rightward arrow A plus B, a single reactant forms two or more products. In a single displacement reaction of plus C, rightward arrow AC plus B, one element takes the place of another element in a compound. In a double displacement reaction of plus CD, rightward arrow AD plus CB, two reactants form two new products. Oxidation investigation. Moistened steel wool is placed in a test tube. Then the test tube with the moistened steel wool and an empty test tube are placed upside down in a pan of water about 1/2 inch deep and set aside undisturbed for 24 hours. During this time, the iron in the steel wool reacts with oxygen in the air inside the test tube to form iron oxide, or rust. 223. Balancing chemical equations. Because the law of conservation of mass dictates that the quantity of each element does not change in a chemical reaction, a chemical equation must be balanced. That is, each side of a chemical equation must represent the same quantity of any particular element. The process of balancing a chemical equation involves determining the coefficients that represent the proportions of whole molecules in the chemical reaction. A scientist balances a simple chemical equation by inspecting the equation and, as needed, changing the coefficient for each chemical formula, beginning with the most complex formula. Ordinarily, balanced equations are written with the smallest whole number coefficients possible. If there is no coefficient before a chemical formula, the coefficient 1 is understood. As an example, consider the equation for the chemical reaction that produces water written as follows. It is not balanced because it shows 2 oxygen atoms on the left side and 1 on the right. To balance the oxygen atoms, a scientist changes the implied coefficient of 1 in front of HO to 2 the coefficient 2. Then the number of hydrogen atoms on the left side of the equation is 2, and the number on the right side is 4. So the scientist changes the coefficient in front of H to 2 balance the hydrogen atoms, making the balanced equation for water.